So hello guys, welcome back to my YouTube channel. Today we are going to start with a new chapter, Rotational Dynamics exercise problem. I hope you are enjoying the lecture series on numerical solving of class 12th physics chapters. So let's start with the first sum. Somehow an ant is stuck to the rim of a bicycle wheel of diameter 1 meter. While the bicycle is on a central stand, the wheel is set into rotation and it attains the frequency of 2 revolutions per second in 10 seconds with uniform angular acceleration. So let us write the solution. We have been given a bicycle wheel and they have said that an ant is stuck on the rim of the bicycle wheel. The diameter of the wheel is 1 meter. So the radius will be 0.5 meters. While the bicycle is on central stand, this means that the wheel is freely movable. The wheel is set into rotation and it attains the frequency of 2 revolutions per second in 10 seconds. Initially the bicycle wheel was at rest, so n0 will be 0, and at a later time t equal to 10 seconds, the frequency is 2 revolution per second. So for n naught we know that omega is equal to 2 pi n. For n naught omega naught will be 0 and for n omega will be 4 pi. So first of all they said that calculate the number of revolution completed by the ant in 10 seconds. So we need to calculate the number of revolution the wheel has taken. We know theta equal to 2 pi n. So in order to find out n equal to theta upon 2 pi. So first of all we need to find out the theta, where theta is our angular displacement. So from kinematical equation we know that s equal to ut plus half at square, where u is our initial velocity and a is our acceleration and t is our time and s is our displacement. For angular displacement theta, this formula will be omega naught t plus 1 by 2 alpha t square. Now we know that omega naught t is 0, so theta will be half alpha t square. Now we know the value of t, that is 10 seconds, but we need to calculate alpha. Now alpha is omega minus omega naught upon t. So omega is 4 pi minus omega naught is 0 upon t is 10 second, which gives you alpha as 4 pi by 10, or more precisely 2 pi by 5. So let's put this value. So we get theta as 1 by 2 pi by 5 into t square. Now t is 10, so t square will be 100. So 2 cancel, 5 ones are 5, 20 are. So theta is 20 pi, which implies our number of revolution completed by the ant will be n equal to theta upon 2 pi, which is equal to 20 pi divided by 2 pi. Pi cancel, 2 ones are 2 tens are. So our n will be 10 revolutions. So for the given time the wheel of the cycle rotates 10 times. Now secondly we need to calculate the time taken by it, that is the wheel of the cycle, for first complete revolution and the last complete revolution. We know that for one revolution theta equal to 2 pi, that is for one complete revolution the angular displacement will be 2 pi. So for first revolution we know that theta is half alpha t square because omega naught t is 0. So this will become theta is 2 pi 1 by 2, alpha is 2 pi by 5 and t square. So pi cancel, 2 cancel. So 5 2s are 10. So 2 into this 5 will be equal to t square, which implies that t square will be 10 and t will be root under 10 seconds. So it takes root 10 seconds for first revolution to occur. Now, in order to calculate the last revolution, we can do one thing, that is, we know the time for all the 10 revolutions, correct? That is 10 seconds. We can calculate the time for 9 revolution, and if we subtract the time that is required for 10 revolution minus the time required for 9 revolution, we can get the time that will be required for the last complete revolution. So let's do that. So we know that for one revolution theta is 2 pi. For ninth revolution theta will be 9 into 2 pi. So on the same note, theta is half alpha t square, that is 9 into 2 pi equal to 1 by 2 pi by phi t square. And similarly calculating this, we get t as root 90 seconds, or more precisely we can write it as 3 root 10 seconds. Let's take this as t9 because we are calculating for ninth revolution. So to avoid confusion, let's take it as t9. So this will be, now putting the value of root 10, we get t9 as 9.4868 seconds. Now we know that the time taken for 10 revolution, that is t10, is 10 seconds. We know the time required for 9 revolution, that is 9.4868 seconds. So by subtracting these two, we can calculate the time to complete the last revolution, that is t will be t10 minus t9, which is equal to 10 minus 9.4868 seconds. This will be equal to 0.5132 seconds. So this is the time required to complete the last complete revolution. I hope you understood this. Let's look at the next sum. Coefficient of static friction between a coin and a gramophone disc is 0.5. They have given us mu s equal to 0.5, that is the coefficient of static friction. Radius of the disc is 8 centimeter. That is, there is a gramophone disc. Okay, this is its center, and the radius of the disc, that is this distance, is 8 centimeter. Initially, the center of the coin is 2 centimeter away from the center of disc. There is a coin placed here, and the distance between them is 2 centimeter. That is, the distance between these two is 2 centimeter. We need to calculate that at what minimum frequency will it start slipping from there. So we know that the radius of the disc is 8 centimeter, which can be converted into meter, 8 into 10 raised to minus 2 meters, right? We need to calculate the minimum frequency at which the coin will start slipping. That is, when this gramophone disc is rotated, it will revolve with some frequency, and as the frequency increases, at a point the coin will start to slip away. So we need to calculate at what minimum frequency the coin starts to slip away, that is f minimum. So when the gramophone disc is rotated, the coin on the surface of the disc will start experiencing some centrifugal force which will be directed away from the center, but the static friction force, that is Fs, will direct the coin in opposite direction. As far as the coin is stable on the surface of gramophone disc, we can say that the static friction force Fs is equal to our centrifugal force. Now we know that Fs can be written as mu s n, and mv square by r in terms of angular velocity can be written as mr omega square. So n is nothing but mg. So this will become mu s mg equal to mr omega square, right? So mm gets cancelled, and omega square will be mu s g upon r. Now we know that omega is nothing but 2 pi f. So omega square will be 4 pi square f square, correct? So we can write, instead of omega square, 4 pi square f square equal to 4 pi square f square equal to mu s g upon r. This gives us f square equal to mu s g upon 4 pi square r. Now putting all the value, mu s was 0.5. Let's take g as pi square. 4 pi square into the radius at which the coin was from the center is this, that is 2 centimeter, which can be written as 2 into 10 raised to minus 2 meters. So pi square gets cancelled, and solving this we get f square equal to 100 upon 16, or more precisely, so taking the square root we get f equal to 10 by 4, which can be written as 2.5 revolution per seconds. Now the next part of the question is, by what factor will the answer change if the coin is almost at the rim? So initially on the gramophone, coin was here 2 centimeter away from the center of the gramophone disc. By what factor the frequency will change at which the coin will start slipping when it is placed at the rim, that is here? The radius will be almost the radius of the disc. So from the previous frequency equation, if you take the relation between the frequency and r, you get that f square is directly proportional to 1 by r, or f is directly proportional to 1 by root r. So we can take this as f equal to k times root r. K is nothing but the constant, which can be all these values mu s g 4 pi square. Okay, so for new frequency f new, when the coin is placed at the rim, let this be k times root under r new. R new is nothing but our radius of the disc. Let's take the ratio of these two. So f new upon the f that we got for when the coin was kept 2 centimeter apart from the center, we get, as these r are on the reciprocal of the frequency, we get f new equal to root under r upon r new. So root under r was this distance 2 centimeter, 2 into 10 raised to minus 2, and the r new, that is the new distance from the center to the coin, is value of the radius of the disc, that is 8 into 10 raised to minus 2. So cancelling this 1 by 4, which is nothing but 1 by 2. So the new frequency f new will be half of the frequency when the coin was placed at 2 centimeter away from the disc. So let's look at the next sum. Part of a racing track is to be designed for a curvature of 72 meter. We are not recommending the vehicle to drive faster than 216 km per hour. With what angle should the road be tilted? By what height will its outer edge be with respect to the inner edge if the track is 10 meter wide? So first of all, solution. The radius of the racing track is given to us as 72 meters, and the velocity at which the vehicles to be driven is not more than 216 km per hour. So velocity is 216 km per hour. So we know that 1 kilometer is 1000 meter, and 1 hour is 60 minutes into 60 seconds, that is 3600 seconds. So to convert kilometer per hour, we need to multiply it with 1000 by 3600, which will be nothing but 5 by 18. In order to convert kilometer per hour into meter per second, we need to multiply the value of velocity into 5 by 18. So this will be 216 into 5 by 18 meter per second, which we get 60 meter per second. Now we need to find out first of all the angle at which the road is tilted. That is, let's take the cross section of the racing track, this part. So this is the curved path, okay, and the road is tilted a bit. That is, this is the normal surface and this is the curve at which the road is tilted, and this is the angle theta, okay, and the width of the track is 10 meters. People get confused with the width, they take this as the width, but this is the normal distance, that is the normal distance between this point and this point, but actually the track is curved, so this distance is the actual distance between the two endpoints of the track, okay, and this is obviously the height. So in order to find out the angle, we know one formula, that is tan theta is equal to v square upon rg. So we know the value of v is 60 meter per second, v square will be 60 into 60 upon r is 72 meters, and g, let's take for simplicity 10. So cancelling this and calculating this, we get tan theta as phi, which implies theta will be tan inverse of phi. By calculating the tan inverse of phi, we get theta as 78.69 degrees. So theta is 78.69 degree. That is, this angle is 78.69 degree, which is a very huge angle for a track. Secondly, we need to find out the height of the outer edge with respect to inner edge, that is this distance. So we know sine theta will be opposite upon hypotenuse, that is h upon hypotenuse is 10 meters. H will be 10 into sine theta, and 10 into sine theta is 78.69 degrees. So this h will be, calculating the sine 78.69 degree, we get h to be 9.8 meter. So this distance is 9.8 meter. This distance does not transverse through the track, but actually the distance between the height of the outer edge and the inner edge. Let's look at the next sum. So this question is also based on the previous conditions of the track. That is, now they have given that the coefficient of static friction between the tires of the vehicle on this road is 0.8. That is, they have given mu s to be 0.8. Will there be any lower speed limit? That is, we need to calculate the V minimum. By how much can the upper speed limit exceed in this case? That is, we need to also find out the V max value. The formula for V minimum, that is V minimum will be equal to root under Rg tan theta minus mu s upon 1 plus mu s tan theta. So putting all the value inside, we know r is 72, g we have taken as 10, tan theta, we got tan theta as phi, minus mu s is given as 0.8, 1 plus mu s is 0.8, and tan theta is phi. So this will be 720, 5 minus 0.8 is 4.2, 0.8 into 5 is 4, and 1 plus 4 is 5. So calculating this, we get V minimum as 24.60 meter per second, and we know that 1 kilometer per hour is 5 by 18 meter per second. So obviously 1 meter per second will be 18 by 5 kilometer per hour, right? So to convert this meter per second into kilometer per hour, multiply it with 18 by 5. So this will be 24.60 into 18 by 5, which will be equal to 88.52 kilometer per hour. Now what they have said is, by how much can the upper speed limit exceed in this case. So the Formula for V max is equal to root under Rg tan theta plus mu s upon 1 plus mu s tan theta. Sorry, here minus will come. Okay, so let's see a condition here. We know that mu s and tan theta, mu s into tan theta is 4. So this thing will become 1 minus 4, that is minus 3, and under root of minus 3 is complex number which is out of our scope. So based on this condition, we can say that the upper speed limit cannot be determined. Another analogy that we can take to, we know that for theta greater or equal to 45 degree, V max is infinity. That is, it doesn't matter what is the maximum value of speed for an angle greater than 45 degree. So the angle that we got, theta, was 78.69 degree. So for this value there will be no upper speed limit, right? The vehicle can go as fast as they want. So I hope you understand both the cases from which we can conclude that there is no upper speed limit for the angle theta equal to 78.69 degree. During a stunt, a cyclist is undertaking horizontal circus inside a cylindrical well of radius 6.05 meters. That is, there is a cylindrical well, radius is 6.05 meters. If the necessary friction coefficient is 0.5, that is mu s is given to us as 0.5, how much minimum speed should the stunt artist maintain? Mass of the artist is given to us as 50 kg. Let's look at the first part of the question. So we have been given the radius as 6.05 of this cylindrical well, where the cyclist is riding his cycle horizontally. First of all, we need to calculate how much the minimum speed is for the stunt artist to not fall while riding the cycle horizontally in the cylindrical well. So we know that V minimum is given to us as root under Rg upon mu s. So R is 6.05 and G, let's take it 10, and mu s is given to us as 0.5. Now calculating this, we get root under 605 by 5, which can be written as root under 121, that will give you 11 meter per second. So V minimum, that is the minimum speed that the artist should maintain to not fall of the horizontal well, is 11 meter per second. What will happen if the speed is increased by 20%? How much will be the force of friction? So consider that if the cyclist is riding his cycle horizontally and it is maintaining a equilibrium, in order to maintain the equilibrium, the mg that is pulling him downwards will be equal to the friction force that is pulling it upwards because of the minimum speed. So we can say that the friction force is equal to mg. For equilibrium, the friction force will be mass that is given as 50 kg into acceleration due to gravity, that is 10. So this will be 500 Newton. So while riding this and to maintain the equilibrium, the frictional force that is been provided up in the upward direction because of his speed is 500 Newton. Another question is that what will happen if its speed is increased by 20%. So you know that after V minimum, no matter how much the speed has increased, the cyclist will perform his stunt horizontally. That is, we need to take care of one thing, that to maintain the speed greater than V minimum. After V minimum, no matter how much the speed is increased, it won't affect anything. So we can say that if speed is increased by 20%, it won't matter. The condition that matter is that if speed is decreasing below V minimum, for that he will fall down. correct? But above V minimum, no matter how much speed you increase, it won't affect anything. I hope you have understood it. Let's look at the next sum. A pendulum consisting of a massless string of length 20 centimeter and a tiny bob of mass 100 gram is set up as a conical pendulum. That is, a normal pendulum of this mass, which is 100 grams, and length L 20 centimeter, is set up to be a conical pendulum. That is, now it is moving. So this will be the height, this will be the length of the string, this will be the angle. Now its bob performs 75 revolution per minute. We need to calculate the kinetic energy and the increase in the gravitational potential energy of the bob. N is given to us as 75 revolution per minute. We can write this as 75 by 60 revolution per seconds. This will be nothing but 5 by 4 rps, or you can write it as 1.25 revolution per second, anything what you want. Now we know the time period, that is the time taken for one revolution, is 1 upon frequency. So time period t can be written as 1 by n, which will be 5 by 1 upon 5 by 4, that is 4 by 5 seconds. Now one formula that we know for time period is t equal to 2 pi root under L cos theta upon g. From this we can say that L cos theta will be t square into g upon 4 pi square. Now putting all this value, we can say that L cos theta will be 4 by 5 square into g taken as 10 upon 4 into pi square. So let's take pi square also, approximately equal to 10. So this will be also 10. 10 10 gets cancelled. So L cos theta will be equal to 0.16. Now notice carefully that this is the length of the bob, and this is the height, and this is the angle it is creating. So if you take the cos theta will be equal to adjacent into hypotenuse, that is h upon L. So L cos theta will be equal to h. So L cos theta we got 0.16. So h will be how much? 0.16 meters. Correct? Now once we have got cos theta, now cos theta is h upon L. So which implies theta will be cos inverse of h upon L, that is cos inverse of h is 0.16 and L was our 20 centimeter, which can be written as 0.2 meters. So 0.2. Calculating this, we get theta equal to 36.87 degrees. Now in order to calculate kinetic energy, that is given by k equal to half mv square, we need to first find out the value of velocity. V is given as root under rg tan theta. R is nothing, radial distance from the equilibrium position to the extreme position of the bob. So R can be written as L sin theta, that is sin theta is opposite upon hypotenuse. So L sin theta will be equal to R. So L sin theta G tan theta. So this will become L is 0.2. So we can also say that V square will be equal to L sin theta G into tan theta. And calculating, substituting all the values here and calculating this, we get V square as 0.9. So substituting this value here, we get kinetic energy as half into mass was 100 gram. 100 gram we can take as 0.1 kg. So 0.1 into V square, which is 0.9. So 0.1, 0.9, 0.09. 0.09 divided by 2 will be 0.045. So kinetic energy will be 0.045 0.45 joules. Now let's calculate the increase in the potential energy of the bob. So initially the bob was at distance L. When this pendulum became a conical pendulum, this was the scenario, right? So this much distance is h and this whole distance is L. So this much distance, let's take it as x, and the change in the position of the bob from here to here, that is this much distance, will be the increase in the gravitational potential energy, because we know that potential energy is nothing but the energy due to virtue of position. So the initially the bob was here, now the bob is here, this much is the change in its position. So potential energy will be mg x. Now you can clearly see that L is equal to h plus x, so x will be L minus h. So putting this, so this is change in potential energy, so mg L minus h, this will be m was 0.1, g was taken 10, and L was 0.2 minus h was 0.16, correct? So this 0.1 into 10 will be 1, and 0.2 minus 0.16 will be 0.04. So the change in potential energy of the bob will be 0.04 joules. I hope you understood this sum. Thank you for watching, and the second part where we will complete the remaining sums will come very soon.